Hi everyone, and welcome to our webinar today on cross-section templates and template components. So we're going to be exploring in detail these two concepts, including the creation of a turning lane at the end. Templates and template components really are the building blocks of road and corridor design, and arguably one of our larger support questions that we get here at Softree. So thank you all for coming and taking the time to review them with us. So a little bit of housekeeping before we get started. First of all, you are muted, but that doesn't mean we don't want you to engage with us. So please, feel free to ask questions throughout the presentation using your GoToWebinar panel. And secondly, like all of our webinars, it is being recorded and it will be available sometime in the next couple of days on our YouTube page. So in the future, even if you can't attend a webinar, feel free to enroll in it, and you'll get an email link directly to the recording after the fact. And lastly, in my final piece of housekeeping, just a little bit of a plug for some upcoming webinars we have. Terrain Tools 101, that's coming up next, mid-February. We have Easy Road and Site Design for Wind Farm Engineering on March the 14th. Low Volume Road Design using LiDAR, that's going to be on April the 4th. And a bit more of an in-depth preview at one of the new features, rather forestry-specific features, I should say, coming up with version 9, and that's cable planning and design at the end of April. So before we get into the actual program and I pass it over to Craig, I did just want to take a second to do a bit of a quick theoretical intro into what we're going to be talking about today. And that really template and template components are the building block of your road or corridor design. And our cross-section templates allow you to set and control parameters such as your road width, your surfacing depths, ditches and shoulders, as well as your cut and fill slopes. Now these templates interact with different things like your topography, your super elevation, your subsurfaces, and your alignments to produce a final cross-section. It is important to understand that these templates are not static. They're basically like mini programs, a collection of logic and rules, and they adapt to each cross-section based on those interactions with the ground and other elements. So Craig is going to be taking some time today to go through just that, through our template components, and to take a look at how we access, modify, and explore their behavior through the template editor. We're going to be reviewing the sequence of template processing, talking a little bit more in depth about ground types, surfaces, stripping, and the role that they play in templates, exploring point codes, parameter overrides, and how to set up a reference feature. And last, or should I say first, because I'm going to be tackling that just here right now, just some of the web resources that we have available, including our e-library. So I'm actually just going to quickly jump out of this PowerPoint and take you over here to our Softree support website. So for those of you who haven't been there, it is a separate website than our main site. It is support.softree.com. And on it, we've got a whole bunch of useful online resources. In particular, we're going to be just taking a look at our knowledge base. It's a collection of articles, tips, and tutorials, and really can provide some useful information if you have a question on templates or are wanting to set up your own customized template. I am just scrolling down here in our knowledge base to our location module. That's where the templates and template editor are contained, and we'll just go down here a little bit further and we get to our section on templates. So our template section contains a whole bunch of different articles, including how to control a guardrail, creating a turning lane, some different examples of things you might want to do with templates, as well as we have our template e-library. And we're just going to go explore that very briefly before I pass it to Craig. Our template e-library contains a whole bunch of different template components that are available through the software, but in this case we're going to get a visual of what a typical cross-section would look like, as well as some more information and details on the parameters contained within them. So if we go explore some of the available roadway components, and we'll just open one up here. So this is our roadway template component called Urban 2. Here's a typical cross-section. Here are some different material assignments that are available within it, and then a list of all the different parameters that you can set and control within the software. So that's a very brief introduction to what's available through our eLibrary. And as I said, all of these are actually accessed through the software itself. This support site can just help you to understand them a little bit better. And with that, I'm going to pass it over to Craig, who's going to take us into the software for more details on template components.
Thanks, Erin. Good morning, everyone, or good afternoon. Just switching over here. Hope you can see my screen. There we go. We're all good. So yeah, I'm going to give you an introduction to some of the concepts to do with templates, template components. And to do that, I'm going to jump around a little bit. So again, please jump in and ask questions when they're topical. So as a project, I've chosen a short couple of kilometer rural road realignment project. You can see here, and it's got a fairly simple road cross section with it. So there are two ways in RoadEng to form a cross section. One is to use what's called a template, and the other is to use what's called a fixed section approach. And the template is a dynamic object. It's intelligent. As Erin mentioned, it's got logic in it and rules, and will change as you change the alignment. Whereas a fixed section is fixed. The beauty of a fixed section is that you can actually just go in and edit it, make it do what you want. But generally, we don't recommend that people fix sections until the final stages of their design, and if possible, not even do it then. The fixing of a section really locks down your ability to change the design in future. So I would avoid that. Of course, you can remove fixed sections, but I would tend to stick with the template. So let's have a look at our template editor. I fired it up here, and you can see, first of all, when you come in, there's a check mark beside the templates that have been defined in this road. And for this design, I only have one template, so I've got the default set. Now these items here at the top level of the tree, each of these are templates. And if I open this up and look inside, you'll see that the template itself is made up of a bunch of components. And as I click on them, you can see they're highlighted where they exist. Here's another one you can see. So all the heavy lifting is done in these components. And I'll explain that a little bit more, but they're kept in underneath a template, and the template itself has some interesting properties. It's got, first of all, a checkbox to include volumes. It's got a checkbox to disable clearing and stripping. This is a bit technical, won't go there now. It's also got crown slopes and a check mark to override the crown slopes from curve super elevation. So you can disable that and set the crown slopes whatever you want. And the final one here is quite interesting, especially for widening projects where you want to match an existing super elevation or crown slope. You just turn that on, and it will pick up the crown from the existing based on an offset from the center line, left and right offset. So that's kind of interesting. Just going to cancel from there. So that's the template level, and below that is a lot of components here. And let's just have a look at the first one. I've got what's called a rural 1 left, and by the way, you'll notice some of these are left and right. In this template here, the components are not designated as left and right. They actually apply to both sides. Most modern components that we ship now have a left and a right side. So if you want this component, you have to copy it and mirror it onto the other side. So let's have a look at what's in here for this roadway component. We've got a whole bunch of parameters, and if I click on them, If it's possible, it will try to illustrate what the parameter applies to. You can see it in magenta over here. So base fill slope, that's the edge of the dirt coming off of the pavement. Subbase thick is set to 0. I could give this some thickness, and there now we have a subbase layer. So each template component has its own set of parameters, and if you sort of poke around in them, you'll get the idea of what the parameter is doing. Here, here's a parameter that says apply super to a pavement shoulder if you have it. So if that's set to 1, then super elevation will be applied to the paved shoulder. Yeah, without going too far, templates have parameters. Each different type of template component has parameters, and you can explore the parameters. As Aaron was mentioning, we have an e-library. Let's just go ahead and bring that in here. And what's in the e-library is a lot of components, template components, which you can mix and match to form templates. So let's just look here. This is revisiting some of the stuff Aaron talked about. Here are some stock template components that are exist in our e-library. There's a more complicated rural one. The other thing I should have probably mentioned earlier is that we are in the template editor environment. So here is our default template that we've got set up. The ground is kind of flat. I can move the template. If I left click and drag, I'm moving the template around. I'm not changing my alignment, but I'm looking at how the template behaves in different ground situations. So it's really useful when you're setting your template up to have this ability to move around, see how if we move into cut, we're going to have some ditching going on and things like that. There's actually another view here where you can look at 4 windows. You can see different ways that the template would behave, or you can go to a station, specific station on the alignment and pick up the ground from there, just to experiment to see how the template behaves. And I think, as Aaron mentioned, this is one of our big support problems, is helping people set up templates. But a lot of it I think you can visually do yourself if you look at the parameters, study the ground situations, and so on. Just going a bit further into the e-library, let's have a look at some of the common ones. Here's a ditch left component, and in the e-library, this is in a folder called ditches and subcuts, and it's not actually attached into a template. I'll show you how to do that in a second, but I can move it around here, and you can see that as the ditch bottom, which is set as a parameter, ditch depth. So when the from the attachment point down at the slope angle is below ground, the ditch will form, and when it's above, it won't. There are other parameters in here that you can change. Sometimes some templates have what's called advanced parameters. If you click on this, you'll see more parameters that are available, and depth from center line. So if this is turned on, the ditch depth is not measured from the attachment point. It's measured from the center line of the alignment. Check outside. 1, it checks the outside of the ditch. If it's 0, it checks the inside. Allow above topo. If you set that to 1, you get a ditch that will form always. It'll form if it's above ground or not. So there's various other parameters here that you can try, and in this template editor environment, you can get a pretty good handle on how that template is going to behave. Let's just have another quick look at some other. There's lots of them here. There's standard slope components. This slope has a cut cut and fill angles, and it has flags whether you can apply that, should apply the template in that situation. Fixed width, so that ties to a fixed offset. So that leg always has a constant width. Lots of others. There's ones that will tie to right-of-ways, clearing zones. So here's one where you have a different angle out to a clearing zone, and then it steepens. So lots of possibilities. And if you're looking to do something special, have a look in the e-library, or just download it and poke through here, and you probably find something that does what you want to do. And if that doesn't work, send us an email and we'll point you in the right direction. So just to carry on a little bit here, how do you manipulate these components? So let's go back up to the default template here. I've got these rural components. Let's suppose I'm going to replace these slope components. I'm going to actually, I'll tell you what I'll do. I'll make a new template. I'll copy this and I'll paste as new. So I have a new template, and I'm going to call this, I'm going to make it into a wall template. Okay, so I've made a copy of what was the default. It's now called wall template. And in here, I'm going to keep the road portion. I'm going to get rid of the ditch because I'm going to apply this template only in a fill situation. And by the way, manipulating these components, a lot of it can be done in the right-click menu. Right-click delete, right-click copy paste, and also flip. If I want to flip this onto the other side, flip left to right. Okay, so let's go into the walls and barriers area here. And I'm going to grab this guy, Gabion fill wall. He's a pretty interesting looking fellow. I'll grab him, right-click, copy. I'll come down here, right-click, paste as new left. And I'm going to get rid of these two components. Right-click, delete. And I'll have a look at the properties of this quickly. So this is a component that represents a Gabion wall structure. There's an offset parameter here, horizontal offset from center line, block width, block height, that sort of thing. So let me try horizontal from profile. So let me try minus, so vertical, sorry. I want this wall offset. Let me do it another way. Okay, I'm going to change the connection for this wall so as to shift it inward a little bit. It's got an offset of -1. I'm going to make it -2. You'll see it's going to horizontally shift the wall under the road. No, too far. Let's go 1.5. You get the idea. When I'm working with components, I'll generally do one side first, get it established, get the parameters correct, and then simply copy and paste the component onto the other side. So now we have a Gabion structure on both sides, and I'm just going to go ahead and keep this XX0 template. Recalc, no, I'm not going to recalc yet. I'll go into assign by range. And here on the first tab, templates, I can assign various templates. So I'll choose the wall template, and I'm going to pick a station range that I've seen, let's say 710 to 770. I looked at this before, which is a fill section. And there we go. So I've set the template, set the station range, pressed add edit, and it's divided up the range so that we have the default template up to 710 and then 710 to 770, the wall template, and beyond that, back to the default. So now if we jump, we'll do a recalc, sure. we jump to that station, 770, you should see our wall template. We have to go a little further. What did I do wrong? Sign by range, probably not 710 to, oh, sorry, I want to go back here a ways. There we go, wall template. So you set the template up and then you apply it to a station range. Oftentimes, it's as a general rule, it's best to minimize the number of templates that you have. It's just a, an organizational thing. I would definitely try to keep the templates at a minimal, and I'll talk about this a bit more later, override parameters or use reference features to force the template to do different things rather than creating, I've seen lots of designs will have 15 or even 20 templates. Really try and avoid that because it's just adding complexity to your design. Simple is good. So, other template concepts I want to briefly talk about are surfaces and volumes. So a template, let me just go back in here, the template editor. Here's our typical road, and it's made up of 2 layers above the subgrade and then material below the subgrade. So that layer, that subgrade line, the materials above it are tracked, and you can actually tell what they are by putting your cursor in here. See, it says SRF2. Put my cursor in here, it says SRF3. You can shade those areas. I shade that, so that's my SRF2. And similarly, I can shade the SRF3. I can shade all areas. So now I've got the subgrade material shaded, and it also reports the area, cross-sectional area of those materials. So it's quite useful for diagnosing what's going on using the shading and the hovering to just see what the materials are. That's fill materials. I can shade cut materials, and then I'll move down into a cut situation. You can see all that's cut material, and yeah, so it's a very useful tool to have. The other thing I want to quickly go into is ground types. RoadEng Software Optimal lets you set up different ground type information, and with each ground type, here's a typical list. This is all user definable. With each ground type, there is a default cut and fill slope, and that can be deployed directly from the template. So you can have different materials with different slopes. So yeah, there's other properties of the materials, obviously things like expansion and compaction factors. So in this design, I've got only one material set. Everything is a material called overburden. So I'm going to assign some subhorizon layers. I do that in assign parameters by range, subhorizons. Click on this plus button. I choose a top layer. Let's go with overburden. And let's go with, I don't know, sand and gravel. And then finally, third layer of rock. Solid rock, that'll do it. And I'll make the layer depths constant, 1, centerline depth 1 and 2. I could also bring in a surface if you had a variable surface and you wanted to track these quantities more accurately. So there, I've got that, and I'm going to assign this to the entire range of stations. So we'll get all these layers. Recalc. And there you can see in my section window, I've got 2 stratum layers below ground. Now, the key, or a very useful feature here is to be able to set the slopes based on the slope of the material, the cut slope. So if I say, let's go in here and say I want my cut slope to be dependent on the material, I set this slope to auto. You'll see this in almost all the slope parameter options. You'll see an option for auto. So I'm going to turn that on for cut, and then I just do it on the left side. I'll move down into cut. Let's turn this hatching off, and you can see what it's doing. As I move down, I'm in rock, very steep. That slope was controlled in my ground type for the rock, more shallow, and finally gentler. So it's quite a useful option to use the ground types, especially if you're in rocky ground or things like that where you want to easily control it. Okay, so we'll just go with that for a second, and let's have a look at another concept here that's related to the templates. Don't need to do this recalc, which is stripping. So I can pre-strip areas, and that's done again in assign parameters by range site prep. I can go in here and set half a meter of stripping, and the outside limits would be slope stake base to slope stake base, left and right. That's on the outside, and then on the inside I'm going to strip right from center line. Add edit. Let's have a look at what that does. So outside slope stake base, inside center line. What this will do after it's done its calculation is it's going to take out half a meter before it even applies the template. There you can see what it's done, and it tracks that material independently as strip volume. I'll talk a little bit more about material reporting in a second. So now if I shade the fill area, you'll see it's filling right down to the subgrade surface. Oftentimes people want to put in a subcut. A subcut is, especially in the prairies, it's a special component here that you would attach to your template, so it wouldn't it'd be subcut under subgrade. That component's used a lot, for other types of site prep. Okay, so there's stripping. Now, again, if you hover in an area, it tells you what surface it is, and I can report those surfaces. I go down here to a data window. I've got this data window set up. Move this out of the way. I've got this data window set up with these columns. I can change those columns to whatever I want. I can come in here and select volumes, and here cut and fill, that's underneath the subgrade. Layer 1, layer 2, layer 3, those are the layers below ground, and then the layers above can be reported here as well. So I could add surfacing. Well, no, sorry, I didn't have any surfacing 1. I had surfacing 2 and 3. So that, those are your surfacing volumes. These are your subgrade volumes. It's all tied together. So the next thing I want to talk about is component connections and the order in which you build components or templates from components. So I'll quickly have a look at that. What the point is here is that the order of these components is important because you form, as you build this thing, you form what's called a merged surface. And if I move this component down, watch what happens. I move it down there. Now I've got my rural component happening right at the end, whereas the the slope component on the left side is happening before it. So it's forming the slope and then processing that and then coming along and doing the roadway after, which obviously is not what you want. So I'll just shift that back up again. What is normal is that a component, like a ditch or a slope, is attached to the outside. So as you add these components in, there's an outside point, and it's right and left are actually independent. So you can think of them, yeah, the order is only important if you're looking at one side. So when the ditch is applied, it's applied on the outside. That's how its connection is set. If you look here, it says connected on the outside. So if the outside happens to be the first thing that's applied, it's going to be at the center line. So it's going to try and apply the ditch at the center line. So it's very common to connect components using this outside flag. You can, in certain situations, you can attach a component to a point code connection. Yeah, so I can attach to a point code, but the disadvantage of attaching to a point code is if the point code doesn't exist, it won't attach. And I'll talk a little bit more about point codes in a second. But the takeaway here is that the order of these things is important. You can copy them and paste them around, but you got to keep the order in a reasonable way so that they connect to each other reasonably. I think I'll leave that at that. So point codes. Let me talk about point codes. Let's go to a section somewhere here in cut. Let's get here. We'll go into the template editor. Okay, so we're in a cut section. We've got our funky slope change here, slopes. But now, what I want to illustrate is that templates have point codes, and they will depend on the template, the components that you're using. Some standard point codes that come with our eLibrary are ditch inside left, DIL, DOL. That's another common one. Point code, points can have more than one point code, but yeah, some of these are standard. A very common one is REL. So those point codes, they can be reported in various ways. For example, in the profile view, I can go in here, profile, and reference point codes. In the profile, I will add ditch inside left, and we'll give it a color that's noticeable. Make it heavy. Recalc. It's a bit slow. I got a lot of points in here, but there you see the ditches are being drawn from the point codes. Similarly, I can report the point codes in another data window. I can add them in here. Data options. I can go in and look for those point codes. There they are, template codes. And there's a whole lot of them. I can scroll through here till I find the ditch ones that I care about. And DIR, DIL. There we go. Let's say DIR, so X, Y, elevation, and so on. Horizontal, vertical offset from center line, original ground elevation. So you can report not only the point code, but the ground information at that point. X, Y, elevation. Somewhere here there should be a station. Oh no, sorry, station, it comes predefined. So there I've added coordinates for those point codes and the elevation of the ditch at that coordinate. So, and all the usual stuff. Copy that to a clipboard, paste it in Excel, or so on. So yeah, again, templates have point codes. How do you find out the point codes? You just poke around. You can move over what you think is an important point for you. DIL, DIR, road edge. These probably won't have point codes, but there is other ways to get that intersection point. Similarly, the surfacing points, you can pick those up for staking, whatever.
So thanks to everyone for joining us for today's webinar on cross-section templates and template components. Unfortunately, due to a bit of a technical issue with our GoToWebinar service provider, we did lose the video feed with a couple minutes left in the presentation. As a result, we didn't get to fully cover everything we included in our agenda. So please take a look at the links below. We've got some great resources outlined for you on creation of a turning lane, template parameter overrides. And of course, if you have any other questions, please feel free to contact us at support@softtree.com. We can answer all of your questions. Thanks again.